begin here talking a little bit about the three-dimensional coordinate system. We have mainly dealt with the two-dimensional coordinate system pretty much exclusively up until this point in our calculus endeavors. So you've got the x, I drew that so small, but you got the x and y axes. Well, calculus 3 here, I guess that's officially what it's called, but for this part of our calculus sequence, we are going to deal a lot with three-dimensional stuff. And so instead of a two-dimensional coordinate system, we do need to add that third dimension, if you will, to it. And so if we represent the x-y axis like this, we add that third one to it, that just gives it depth, right? And so it would be an axis that would come out straight from the board and straight into the board, back behind the wall there. And so that would give us that third, so we could put points in space, if you will. Now, the way we typically orient it, though, instead of that way, because that would be hard to draw, kind of tilt it a little bit. And, oh, the other thing before I move to that, the two-dimensional system also, we didn't use this notation much, but a notation we'll see for two-dimensional coordinate systems is this R2, which, you know, it's R, special looking R, but that's kind of for the real system. So you've got, what that basically means is you've got two real number lines overlaid on each other. When we go to the three-dimensional, yeah, like I was saying, instead of drawing x and y axis here, what they typically do is we put the xy axis, actually we do this, we'll call the up and down, that'll be our z axis, our third axis. Then we put the y axis, kind of where the x axis normally is. And then it turns out the x axis comes in kind of at this angle here. This is how we typically orient. I mean, we can orient how we want, but that's typically how we actually orient this three-dimensional system, where, you know, the x-axis is, it's coming out of the board, but it's not straight out of the board where you can actually draw it. So our regular xy axis here is, well, it's kind of, if you think about this kind of in this room here, or any room, the xy axis is kind of the floor, right? This is the floor of a room, then here's below the floor, and here's above the floor. That's kind of, and I guess you could make the corner of the room the x-axis, got your y-axis. Anyway, it's just a little different, that's for sure. It's hard, and it's harder to draw, for me anyway. It's harder to draw stuff in three dimensions. We'll get a little bit of practice. But anyway, yeah, we've got three real number lines oriented here. So, yeah, if they refer to R3, R cubed, that's just referring to the three-dimensional coordinate system. Okay. All right. And so, where's positives and negatives and all that? Well, the positive x-axis is this one that comes forward. So these are positive x's. Positive y's are just like positive x's were. Those are the positive y's, and then of course the z's are positives up here. So yeah, the x is, I guess, is the one maybe to get used to, but yeah, the positive x's are the ones that come out like that, and so the negatives are back there. there's 4 quadrants in two-dimensional space, so there would be 8 different regions, I guess you might call them octants. When you go to 3-dimensional space, because you're breaking it up quite a bit more. But it's just harder to visualize, harder to draw. So let's see, 1, 3, 4. And so again, these are ordered in order, just like we know that 1, 2, well, that's x is 1, y is 2. Well, here, same thing, right? This is x, y, z. It's in order triple. X is 1, y is 3, z is 4. So 1, 3, x is 1, and then the y is 3 would be, so x is 1 is here, and then y is 3 would go 3 units in the y direction. So 1, 2, 3, put us right about there. And then that would be 4 in the z direction, so that would be 4 units up. Yeah. So it's just hard. I mean, that still looks like it could be anywhere, doesn't it? It's just hard. It's hard to draw in 3 dimensions on 2-dimensional flat surface. So. But yeah, it's out here 1, and then over 3, and then up 4. So if we follow along, it's out this way, and then back this way, and then up. So it's kind of hanging out here, but it's it's just hard to see. So it's our challenge. But pretty much the same x, y, z. You're going to run into the same stuff as you do with the x, y points. Now, one thing to be able to do is recognize what certain things are in 3-dimensional, in R3, R cubed. So what surface, let's see if we can identify, what is the surface in R cubed here? Number 1. What surface would it be if I said you got z equals 2? Well, z equals 2, as far as the surface goes, if you think about it, that since I just specified that z is 2, x and y could be anything. And so we're going to put all the points where you could have x, y, and then the z is 2 together. Well, this helps or not, but x and y can be anything. And so if you kind of think about that a little bit, what you'll have is all these points. Basically, what you're going to do is get all the points that are at a height of 2. I mean, that z is kind of the height here, if you will. If you can get that concept down, that helps. So it's all the points that are at a height of 2. Well, if you think about that, so I've got all these points. So I've got all the points in all directions, z equals 2. Well, put that all together, and what you wind up with is, I should draw it over here. So here's z equals 2. And so you've got all of these points put together. And so what you wind up with is a plane. It's the plane at z equals 2 level. Make sense? Because all the x's, so this would be one of the points in that plane, and then you have another point. So it's what's varying there is the x. The z value is always constant. So yeah, a z equal 2 would be just a plane at the height of 2. Now if we go, and that's analogous to over here, if I do like x equals 1, to make the analogy here, x equals 1, well that would be just a vertical line, because the y can be anything. you see. So when you go to 3 dimensions, that variable equals a number, it turns into a plane instead of a line, right? You see what I'm saying? So, so there's those little things. This is a vertical line in r cubed. This is a plane in r cubed. So what would this be? X equals 4.